In parallel, when machining a continuous 5-axis toolpath, sometimes we encounter problems when the tool axis passes close to the machine tool pole, which is typically the vertical axis, or Z, where the A or B axis is controlling the elevation and the C axis controlling the azimuth angle. As we approach the pole, the tool axis may have to go through a very rapid change between points as it passes through or close to the pole. What this looks like is as the machine approaches the vertical, the table will rotate at 180 degrees while the machine tool dwells in the same point. This can leave marks on the machine, and it also increases machining time. One solution to fix this is to avoid going through the pole at all costs. The option we can use is to redistribute points when the maximum separation angle is used in the settings. However, this can also cause problems, particularly in 4-axis toolpaths when the rotary axis is horizontal. So in this example, we have a table machine. I'm just going to run the simulation to highlight the problem areas. So if I press play, we can quickly see that as the machine tool approaches the vertical of the Z axis, the table rotates 180 degrees. If I turn off the machine tool, the tool and the part, and if I zoom into points close to or on the Z axis, we can see that there are a lot of points being used around the pole. If I keep zooming in on these, we can see that they're almost infinite, and when we get extremely close, we can see that they create a non-straight toolpath. This is to try and avoid the pole, and this is not ideal. So what we need is a method of clearly defining the position of the pole within parallel. Behavior of the toolpath around the pole should be definable to give the best results. What we want to do is maybe avoid the pole or force the tool axis through the pole. If we have a machine tool defined, then that should be used to determine this behavior. So if I just fully zoom out and turn back on our model, our machine tool and tool, I'm going to turn off the toolpath points and then open up a toolpath strategy. So what we have now in our machine tool form, if I select the table machine tool, we now have the option to allow use of machine tool information. If we use machine tool when possible, we are giving PowerMill the option to force the machine tool through the pole or to avoid it in order to reduce excess movement of the C axis. So now that I have these set, I can calculate the toolpath. And if I simulate from start, just turn off the points to make it a bit clearer, we can now see that there is no excessive C-axis movement. In fact, there is none now. The machine tool is passing exactly as I want it to, without dwelling around the pole or without rotating the C-axis. Again, I can turn off the machine tool, the tooling and the model. If I turn off my toolpath points, I can then zoom in close to or on the Z axis, and I can see that where we had multiple points before, we now have a regular point separation. Also, the points follow in a straight line and no longer provide a jagged toolpath around the pole. This update in PowerMill is giving the user control over the behavior of a tool axis when the tool is approaching the pole.